Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the division of polynomials using the coefficient comparison method. Recall, from the long division of polynomials video, we had the dividend p of x and the divisor d of x, giving us the quotient q of x. Then, with the p of x as the subject, we are saying that we would have p of x is equals to q of x times d of x. Now, we add the remainder term, r of x. Right, with that in mind, we are going to look at some facts. So remember, p of x is equal to d of x times d of x plus r of x. This one should be equation 1. So we'll keep on referring to this equation. That's why we labeled it as equation 1. The remainder r of x cannot be one that has a degree that is higher than that of the divisor. So in a nutshell, we are saying the remainder r of x can at most be 1 degree lower than that of the divisor d of x. That is, if d of x is a quadratic expression, then r of x can only go up to be a linear expression. Therefore, r of x cannot be of a degree higher or equal to that of d of x, that is the divisor. Great. So now let's look at the steps of obtaining the quotient and the remainder using the coefficients comparison method. Step 1. Substitute the general form of both the expected quotient and the remainder in equation 1 on the right-hand side, or RHS. Step 2. Expand or multiply the brackets or parentheses on the right-hand side, RHS, and compare with the coefficients on the LHS, that is to say, the left-hand side. Step 3. Solve for the unknown terms. Great. So now let's dive into example 1 with these steps that we have. So with example 1, we have x plus 1 is a factor of x cubed plus 3x squared plus x minus 1. Find the quotient. So we already know that if x plus 1 is a factor, it means that there is no remainder, or the remainder is just equal to 0. So we just drop the 0 term. Now, looking at that, we are going to have this in mind. We know that if we are going to divide a dividend, that is a cubic function, by a linear function, what we get is a quadratic function or expression. That is to say, x cubed divided by x, we get x squared. Then the general form of q of x is q of x is equal to ax squared plus bx plus c. As easy as that. Right. So now we are going to substitute where our a, b, c are elements of real numbers. Substituting into the right-hand side of equation 1, we would get that. And the next step, of course, is to expand the parentheses or brackets. After we expand, we would get to that stage. And of course, we group the like terms so that we simplify our work. Simplifying our work, we would have that. And remember, this is an identity. That's why we have the 3 lines instead of the equals to. Right, so with that, we now move on to compare the coefficients. The coefficients of x cubed on the left-hand side with the ones that are on the right-hand side. So we see that on the left-hand side, we have 1, and on the right-hand side, we have a. So a is equals to 1. For x squared, we see that on the left-hand side, we have 3, whilst on the right-hand side, we have a plus b. And also from the previous solution, we had a is equals to 1. We substitute for a, that is 1. We solve for b to get b, that is equal to 2. For x to the power 1, or just x, we have the coefficients being b plus c is equal to 1. Substituting with the b that we obtained of 2, we get c to be minus 1. And for the constant term, we have a c on the right-hand side and a minus 1 on the left-hand side, meaning that the c is equal to minus 1. Right. What it means then is that we can now substitute for the a, b, c in the quotient so that we get our answer as x squared plus 2x is equals qx is equal to x squared plus 2x minus 1 as our solution. Right. So now, moving on to the next example. So in the next example that we have, we are looking at this particular example. So with the example here, we do not know if this is a factor because we are just given the dividend and the divisor, and we are asked to find the quotient and the remainder. So dividing a quadratic equation, or rather quadratic expression, by a quadratic expression gives us a quadratic expression. That is to say, x to the power 4 divided by x to the power 2 is equals to x to the power 2. So the general form of the quotient q of x is ax squared plus bx plus c. And then we have the general form of the remainder, which is r of x is equal to ax plus b. Now, we include this one because we don't know if we're going to have a remainder, but just to be on the safe side, we just include it. Great. So now we substitute this into equation 1. Of course, a, b, c, the small letters, and a, b, the capital letters, are all real numbers. Great. So when we substitute for that, we expand the brackets or parentheses. After expanding the brackets and the parentheses, we move on to group the like terms. After grouping the like terms, what we have is that. Now, we move on to the next step of comparing the coefficients. So we are comparing the coefficients of all the terms in the left-hand side with the terms on the right-hand side, starting from the coefficient of x to the power 4. So with x to the power 4, we get a is equals to 1 because we are saying that the coefficient of x to the power 4 on the left-hand side is 1, whereas on the right-hand side, it's a. So a is equals to 1. Great. So x cubed, we have b is equals to 0. Why? Because on the left-hand side, we don't have the x cubic term. That's as good as a 0. So b is equal to 0. Now, for the coefficient of x squared, we have 4a plus c is equals to 0. Substituting with the a that we obtained, which was a 1, it means that our c becomes minus 4. Moving on to the coefficient of x, we have 4b plus a, capital letter A, is equals to 0. So substituting with the b is equals to 0, a becomes 0 once again. So meaning that the a term in the remainder is 0. X naught, that is the constant term, we have that 4c plus b is equals to 16. Substituting with the c of minus 4, the capital letter B for the remainder becomes 32. So what does this mean then? This means that our quotient is going to be x squared minus 4. Whereas our remainder is a 32. As easy as that. That's how the method works. Now let's get into example 3. With example 3, we have a quadratic being divided by a quadratic. So we are asked to find the quotient and the remainder of this. So knowing that a quadratic divided by a quadratic would give us a quadratic expression, we would consider that in our expected quotient. So our expected quotient will be of that form, the quadratic form. And then we have our remainder, which is 1 power, or rather 1 degree lower than that of the divisor. Right, so with that, we are going to substitute into equation 1. So recall A, B, C, and AB, the capital letters, are all real numbers. So we substitute. After substituting, we expand the brackets. And after expanding the brackets, we move on to grouping the like terms. So as we group the like terms, we would get that is our identity. So with that in mind, we are going to compare the coefficients of x. So starting with the highest power of x. So in this case, we have the quartic. So x to the power 4, comparing the left-hand side with the left-hand side, the left and the right-hand side to be precise. So a is equals to 1. That's one thing that we got. Then for x cubed, b minus a is equals to 1. Substituting for a is equals to 1, it means that b is equals to 2. For x squared, 4a plus c minus b is equals to 3. Substituting for a, that was a 1, and a b, that was a 2, our c becomes 1. So now moving on to the coefficient of x, 4b minus c plus the capital letter a is equals to 0. Substituting for b and c, we get the capital letter of a being 5. Then for the constant term, 4c plus capital letter b is equals to 6. So meaning that the capital letter b becomes 2. Then our quotient, then substituting for a, b, c, the small letters, we are going to get x squared plus 2x plus 1. And the remainder would be 5x plus 2. So this was an interesting question, I must say. So if you've made it this far, I say congratulations to you. However, I leave you with the following task. Use the coefficient comparison method to solve the given task. Thank you so much for watching Numbers Simplified. Hit that subscribe button